Hey there! Gearing up for that big AS physics exam? Well, you've come to the right place. In just the next few minutes, we're going to arm you with the key strategies you need to absolutely smash that multiple choice paper. Let's get right into it. So, first things first, let me ask you something. Think you know the exam's biggest secrets? Because here's the thing, it's not just about what you know, it's about understanding how the exam is built. And that's exactly what we're going to pull back the curtain on. Think of this as your personal insider's guide. All right, let's kick things off with what I like to call the unwritten formula sheet. Yeah, these are the super important equations that the official datasheet loves to forget, but the examiners totally expect you to have locked in your brain. Knowing these is your first real advantage. Okay, first up, the real definition of force. Look, we all know F equals ma, right? But this is the OG. Force is the rate of change of momentum. It's a much more fundamental way to look at things, especially when you get those tricky questions about collisions or impulse. And this leads perfectly into a super common graph question. The second you see a momentum time graph on your exam, your brain should scream one thing: gradient. Seriously, the steepness of that line at any point is the resultant force. That's a guaranteed mark right there. Moving on to work done. Please, please, please don't forget the cos theta. It's so important because only the bit of the force that's actually pointing in the direction of motion is doing any work. Think about it. If you're pulling a suitcase at an angle, you only care about the force pulling it forward, not the bit lifting it up slightly. Okay, this next one is a lifesaver, a fantastic shortcut. While power is work over time, you can also get it just by multiplying force and velocity. This formula is your best friend for any question about something moving at a constant speed, like a car just cruising down the highway. Now, this one can look a little scary, I get it, but trust me, it's just a simple two-step process. First, you find the biggest possible order number, n, by plugging 90 degrees into your grading equation. Once you have n, the total number of bright spots you can see is just 2 times n plus 1. That plus 1 is for the bright one right in the middle. The infamous I equals MVQ equation. It looks like a mess, doesn't it? But really, it's just telling a story. You've got the area of the wire, times n, which is just how many charge carriers are packed in there, times v, their average speed, times q, the charge on each one. Just know what each letter means, and you've cracked it. Okay, let's switch gears. It's time to play detective and spot the traps. Examiners absolutely love to hide little tricks in the multiple choice questions. So let's shine a spotlight on the most common ones, so you can just walk right past them. So picture this, a classic question. A box is just sitting there on the earth. Its weight, W, is pulling it down. The question asks, what's the other force in the Newton's third law pair? And, almost everyone points to the upward force from the ground. And that's exactly the trap. Here's the secret to not falling for that. Newton's third law pairs are always about two different objects, and it's always the same type of force. So the partner to the earth pulling the box is the box pulling the earth. The upward force from the ground is just an equilibrium force acting on the same object. Big difference. Okay, this slide looks almost insultingly simple, right? But I'm telling you, this is probably the #1 reason people lose easy marks. Unit conversions. You have to remember, when you're converting a cubed unit, you have to cube the conversion factor. A centimeter is 10 to the minus 2 meters, so a cubic centimeter is 10 to the minus 2 cubed, which is 10 to the minus 6. You have to know this. All right, pop quiz time. This is a classic waves trap. A question tells you the total distance that covers 5 bright interference fringes. To get the width of just one fringe, what do you divide that distance by? Is it 5? The answer is no, and that's the trap. You don't divide by the number of fringes. You always divide by the number of gaps between them. So if you have 5 bright fringes, you have 4 gaps. You divide by 4. It's such a simple trick, but it gets people every single year. Let's talk about a projectile right at the very top of its arc. What's going on? 3 things you need to know. 1, its vertical velocity is 0 for just an instant. 2, its horizontal velocity is still going strong. It hasn't changed. And 3, the only force acting on it, the resultant force, is just its weight, pulling it straight down. All right, next section. Let's talk about mastering units and vectors. Honestly, this is where you can scoop up some really easy marks that other people just throw away. These are the fundamentals that hold everything else up. Look, there's no way around this one, you guys. You just have to memorize the 6 SI base units. They are the absolute building blocks for everything else in physics. Let's run through them. The kilogram, the meter, the second, the ampere, the Kelvin, and the mole. Got it? Good. Now this is like your secret weapon for checking if your equations even make sense. Let's try to break down the volt. You start with a formula you know, like V equals work over charge. Then you break down work into its base units, do the same for charge, and then just combine them. It's a fantastic way to see if an equation you've written down is even possible. Scalar versus vector. This one catches people out all the time. Just remember, work, energy, and power, they're all scalars. They just have a size. But momentum and electric field strength, they are vectors. Direction is everything. Knowing the difference is crucial. Okay, home stretch, this is our particle physics power-up, a super fast review of the key facts that often pop up as one-mark questions. Knowing these cold will give you that final edge. Let's do this. Just burn this into your brain. A proton is made of 2 up quarks and a down quark. Up, up, down. That gives you the +1 charge. A neutron is 1 up and 2 downs. Up, down, down. That makes it neutral. Simple as that, done. So what's really going on in beta minus decay? It's deeper than just a neutron becoming a proton. On a fundamental level, one of the neutron's down quarks literally flips and becomes an up quark. That's the tiny change that causes the whole thing. All right, mission debrief. What are the big 3 things to take away? 1. Know those unwritten formulas inside and out. 2. Always spot the trap by asking, are these forces on one object or 2? And 3. Check, double check, and triple check your units and your powers of 10. So we have covered a lot really fast. You're now officially an insider. So my final question to you is, armed with all this knowledge, which one of those classic exam traps are you going to be looking for first? Go get 'em, and good luck.